Welcome back to another edition of Who Wants to Be a Mathematician? I'm your host, Mr. Hill, coming at you with some AP Calculus. We're going to be doing some derivative information to graph information. So we've been doing the first derivative and second derivative over the past week or so, and it's useful information, but what does it really tell us? Well, it tells us how to graph a function. So here we go. We got a bunch of different information here, and we're going to figure out what the graph looks like given all of the information. So we'll start at the top. So we know f of 0 is 2, so that's just a point. We're going to draw that point. F of 2 is 1, draw that point. F of 4 is, where did it go? Oh my gosh. So f of 0 is 2, f of 2 is 1, f of 4 and f of 10 are 0, so 0 and 0 here. F of 6 is negative 4, so 6, 1, 2, 3, 4. We know it's down here. So that's what the first line says us. The second line tells us is f prime of 2 and f prime of 6 is 0. Well, we know the derivative is equal to 0 when we have a minimum or a maximum. So we know it's either going to be a minimum or a maximum at that point. So at f of 2, this is either going to be a minimum or a maximum. And at f of 6, this is either going to be a minimum or a maximum. We're going to have to wait to see what happens there. F of 4 does not exist. F prime of 4, excuse me. And f prime of 10 does not exist. So that means that we either have a cusp or we have a turn, something like that. So we know f prime of x is greater than 0. So if our derivative is greater than 0, that means our slope is greater than 0. So our slope is positive between 6 and 10. So let's give our f prime of x information. Let's do it up here. So between 6 and 10, we know our slope is going up. We know f prime of x is less than 0 between our negative infinity up to 2. So we know our slope is coming down here. Between 2 and 4, so 2 and 4, we have a downward slope. Between 4 and 6, we have a downward slope. And then 10 to infinity, we have a downward slope. So now let's move on to the double derivative. F double prime is greater than 0. So if f double prime is greater than 0, that means concavity. F double prime is concavity. So if it's greater than 0, then it's concave up. So between negative infinity and negative 2, we are concave up. Between 4 and 10, so between 4 and 10, we're concave up again. And from 10 to infinity, we're concave up. Now, we have f double prime, so this one here, f double prime of x is less than 0, so that means we're concave down between 2 and 4. So given all of this information, we're going to put this graph together. Here we go. So between negative infinity coming all the way up to 2, we are decreasing but concave up. So we're going to look something, let's do a different color just to change it up a little bit. We are decreasing, so we're coming down, but we're concave up. So between our next 2 points, we know that this point right here has either a maximum or a minimum. So that means we have to turn. So we know we're concave down, but we're also decreasing. We also know it's a maximum or minimum. Well, if we're concave down, from concave up to concave down, it's going to be a minimum. So we know we're doing something like this. At 5, we know that at 4, we know it does not exist. So it's either going to be a cusp or a turn. It looks like it's going to be a turn because the next section, we're still going to be decreasing, but we're going to turn to concave up. So we had a minimum here. We're coming down, and looks like we're going to do a turn-a-roo. So we come down to this point. This point, we are increasing our slope, we're still concave up, and we know it's either minimum or maximum. So we come up here. At 10, we know that it does not exist, so it's going to be either a turn or a cusp. To me, if we're going to be decreasing our slope but concave up, we are going to come up to a point. We have to be concave up but decreasing. So here we go, and it looks something like that. So this is what our graph looks like. So with all of our information, we created this graph. So my suggestion on the next one, that yes, you're going to have to do by yourself, you put in what you know for your first derivative. You put in what you know for your second derivative. And then at your single points, you put in what you know for these points. And that will help you graph what's going on. So I'm going to leave the next one up to you guys. Pause the video, work through this, and then come back, and I'm going to have it working out with you. So pause the video, because I'm going to work on it now, and here we go. So first, f of 0 is 2. So 0, 2. That's a point. I can do that. F of 2 is equal to f of negative 2, which is equal to 1. So f of 2 is equal to 1. Whoop. F of 2 is equal to 1. F of negative 2 is also equal to 1. We know that f prime of 0 is 0. So that means there is no slope at that point. So that means that this point is either going to be a minimum or a maximum. That's what this point is going to be. We know, so let me write that somewhere where we actually can see it. So it's going to be a minimum or a maximum down at this point. So we know our derivative is greater than 0. So that means it's increasing in slope if x is greater than 0. So we're going to come up here and we're going to say our f prime of x right here from 0 onwards is going to be increasing in slope. And now we also know that our f prime of x is less than 0, so it's decreasing in slope when x is, oh, I did that backwards. When x is less than 0, we're going to be increasing in slope. When x is greater than 0, we're going to be decreasing in slope. So that's what our prime tells us. Now let's look at our f double prime of x. If x, the absolute value of x, is greater than 2, so give me any number that's absolute value is greater than 2. So think about this a little bit. If you give me negative 4, that's greater than, that absolute value is greater than 2. Negative 3, that absolute value is greater than 2. 3, that absolute value is greater than 2. So that means from this point and this point in this direction, we know that f double prime of 0 is greater, double prime of x is greater than 0. So that means it's going to be concave up. So if it's greater than 0, it's going to be concave up. So for both of these, we're dealing with concave up. So for the other one, when f double prime of x is less than 0, it's going to be between these two values. So we're concave down here. So now, let's bring it all together. We know at the pink dot, we have a maximum or minimum. We know that we're going to be increasing from negative infinity up to that pink dot because of our f prime. We know that we're going to be concave up because of our double prime. So let's draw what it looks like. So we're going to be increasing and concave up. So we're going to look something like this. Concave up, concave up, concave up, concave up. And now at this point, we know it's going to be a minimum or maximum. Oh, just kidding, just kidding. We know from negative infinity up to 2, we're concave up. Right here, we're concave up. So we know from here, we're concave up. And we're still increasing in slope, but we're concave down, so we're going to be going up like this. So at that pink dot, we know we're a minimum or maximum. We know on the other side of this pink dot that we're going to be still concave down, but we're going to be decreasing. So concave down and decreasing. So at this point, we're going to turn to concave up, but we're still going to be decreasing. So that's going to look something like this. So it kind of looks like a bell curve. So if we get rid of all the crazy, that is what your curve should look like.